So we've been doing all this stuff by hand, and what we're going to learn today is how to do it in the calculator so that you don't have to. Okay? So like for that one that we did in the bell ringer where your vertex was really messy, we're going to figure out how to do that on the calculator so you don't have to do any of that by hand. Okay? Alright, so the first part we're going to do though is review how to solve by hand, because that is something that you need to know how to do. They're going to make you do it on the inactive section of your exam, and you're going to have to do it on the inactive section of your test in this class next week. So we've got to know how to do that. This was what you did yesterday in that homework, right? So what's step 1? Set it equal to 0. So we're good on 2 out of the 4 here. What is step 2? Which is part of factoring. So check for a GCF. Is there one? No. And it's a trinomial. Our leading coefficient is 1. So how are you going to factor that? Drop it low. So set up your parentheses. What do you drop first? What do you always keep? Second sign's a plus. So what does that mean about your answers? They're the same. So we need another plus. What are factors of 12 that add to be 8? 6 and 2. So once you're factored, what do? Set your factors to 0. So x plus 6 equals 0. X plus 2 equals 0. When you solve x plus 6, what do you get there? X equals negative 6. And when you solve x plus 2, what do you get there? Negative 2. Remember, we have to change our signs there. Is that okay? Questions? Wonderful. Next one. Are we equal to 0? Yep, so we need a factor. Is there a GCF? No, so we're going to go ahead and drop it low because it's a trinomial and your leading coefficient is a 1. So we'll drop our x's. We'll keep that first plus sign. The second sign is a minus, so what does that mean about our answers? Opposite, so we need a minus there. What are factors of 60 that subtract to be 4? So just make sure you put the bigger one first. Is that okay? Alright, then set them equal to 0 and solve. So x plus 10 equals 0. X minus 6 equals 0. When you solve x plus 10, what do you get? When you solve x minus 6, what do you get? Questions? We remember how to do this? Is it coming back to you now? I think we were a little foggy yesterday, but it's better now? Yeah? Okay. For the next one, what do we need to do first? Equal to 0, so we'll say 3x squared minus 7x plus 4 equals 0. Is that alright? How are we going to factor this one? What's that called? Or what have we been called? Rainbow, yeah. So x squared minus 7x plus 12. We need factors of 12 that add to be 7. So we're going to have x, drop the first sign. The second sign is a plus. So what does that mean about our answers? So if we already have a minus, we need another minus. What are factors of 12 that add to be 7? 4 and 3. All this equals 0. Set each factor to 0. Are we ready for that yet? When you rainbow, what do you have to do? Don't forget to divide. So 4 over 3, will that reduce? So what do? Denominator to the front. That's going to give us 3x minus 4. And then what about 3 over 3? Will that reduce? What do you get? So x minus 1. Now can we set them equal to 0 and solve? So from the 3x minus 4, what do you get when you solve that? Do you remember how to do that? For the, when you get x by itself here? Do you remember our little trick for that? So we know that if it's just like x minus 1, what do you get? 1. You just change the sign, right? What's different for this one? Number in front of x, so what do you do with that? You divide by 3. So y'all remember how we said it's basically going to be this number? Go before you swung it to the front. It's the same thing. So just change the sign for that, and it'll be 4 over 3. And if we go through and solve that out by hand, you get the same thing. So we would have 3x equals, add 4 to each side, so you'll get 4, then divide by 3, x equals 4 over 3. You just kind of skip all that. Is that okay? If you need to do that, then absolutely do that. Do not get it wrong, okay? So if you don't remember the little cheats, then just do it the long way. That's totally fine. I'd much rather you do that and get it correct than get it wrong because you couldn't remember our little cheat codes. Questions on any of those? So looking at the next ones, so this is getting into like what we're talking about today. So we're going to start looking at word problems. So with quadratics, they're only going to ask you for really 2 types of things. They're going to ask you to find your minimum or your maximum, and they're going to ask you to find your zeros and your roots, okay? So words that they might use for minimum or maximum are like highest. They may just say flat out maximum or minimum. They may use something like lowest instead of highest. Let me see what else. About it. I mean, if they're asking you to find the minimum or maximum, they're probably going to use the word minimum or maximum to get you there. So that one's not going to be too tricky. If they're asking you to find your zeros or your roots, the most common thing that they're going to use is hit the ground. That's what they really like to say there. So they're going to ask you, like, they'll say a ball is thrown. Its path in the air is modeled by this function. When does it hit the ground? So that wants you to find zeros. So it'll be something like that. Then they also say, like, when does it land? So again, if you're like throwing a ball and it's modeled by some equation, when does it land? That wants your zeros. When does it land? But most of the time, they're going to say hit the ground. So anytime you see the phrase hit the ground, you're thinking zeros. If you don't have a calculator, how are you going to find those? What do we do all up here? Factor and solve, okay? So I want you to make a note of that up here. If it says hit the ground, you need to factor and solve. So anytime you see the phrase hit the ground, what are you going to do? Factor and solve, yes? That needs to be like memorized for sure, for sure. What else am I going to pick here? So like I've been saying, they're going to talk about like throwing a ball or launching a rocket. They may talk about somebody like jumping into a pool or jumping off of a cliff, something like that, like into water, not just to end their lives. That was funny now. Okay. So for these types of problems, what is x going to be? What variable does x represent? Y'all remember? We said x is usually one thing. Like, is it height or time or money? What is x always going to be? Time. It is domain. You're correct. And that was very vague. I'm sorry. That was not good. That's not a good question. So then for y, for these problems, a lot of times it's going to be your height. So they may ask you at what time does it reach its maximum point? That wants the x value. They may say, what is the maximum height that it reaches? That would want a y value. So you just need to know that x is time and y is height. So I'm going to box those in because that's kind of a little different than the other stuff over here. Yeah. Are we okay so far? Y'all ready to try some?
Wait, is that weight or
Height?
height? It kind of looks like height.
No, it does not. It's just my E is connected. It's like almost cursive. I know y'all don't know what that is. So it's height. X is time, Y is height. And that's like always going to be like this. So, yeah. Let's try some? Yes? Okay. So, for the first one here, a cat is walking along the railing of a balcony and knocks a flower pot off the railing. And this function is going to give the height of the flower pot after t seconds. And when it falls from a height of c feet, so they got c in there, we're going to have to replace that. It says that the cat is 64 feet high. That's your starting height, right?
Yeah.
So that's your C value.
64 feet.
I mean, maybe it's an apartment building and it's like up a couple floors.
He was landing.
The cat is not falling. It's a flower pot. It's fine.
The cat would have landed on his feet.
So I replaced that 64 with the C because that's where you're starting. That's your starting height. That's also your y-intercept, yeah? That makes sense? So we're starting to put all these little things together. Okay, so it wants to know how long it's going to take the flower pot to reach the ground. What does that want you to find?
How long it takes, so it's the X value.
Your zeros. So when it says reach the ground, that's zeros. And it says how long, that tells you we want the X value. So we want time, yeah? So anytime it says reach the ground or hit the ground, what are you trying to find? Zeros. How do you do that? Factor and solve. Yes, so that's what we're going to do here. So when you're factoring, what do you look for first?
GCF.
Do we have one here?
Yeah.
What is it probably going to be?
16.
I would go with 16. I would always try your leading coefficient first. Because that's like, if you can get rid of that, it's going to make factoring a whole lot easier, right? Because we don't have to worry about doing rainbow or anything else crazy like that. So, let's see if 16 will work. Will 64 divide by 16?
Yes.
And what do you get? 4. So, I'm going to pull out a negative 16. Because do we ever want our leading coefficient to be negative?
No.
If we can avoid it, we don't. So, let's pull that out. We're going to pull out negative 16. And then we'll have t squared minus 4 left inside. Is that okay?
Wait, what?
We divided both of these by negative 16. And that led us here. That's just pulling out a GCF. That's a long time ago. We did that a really long time ago. Feels like it now. It was probably only a couple weeks ago, but man, time flies. So, what do we do from here? We pulled out a GCF. What else can we do? Can we factor any further?
Wait, yeah.
How could you factor this stuff inside?
The DOS.
What does DOS mean?
Difference.
Difference of squares. Do y'all remember that?
Yeah, I forgot how to do that.
Okay, so set up parentheses. What's the square root? You're correct. We need a plus and a minus in between. What's the square root of t squared?
T.
T. What is the square root of 4? 2. So you're going to have t plus 2, t minus 2. Is that okay?
Isn't that what they say that for?
That's what I would
I think so.
It's like the T minus 2.
So once we've factored, what do you do? Factor, then set them to 0 and solve. So from t plus 2, what are you going to get?
T minus 2.
Equals negative 2. And then from t minus 2, what do you get? Positive 2. From the negative 16, if we say negative 16 equals 0, does that make any kind of sense?
No.
Is that going to be helpful at all?
No.
No, so you don't even have to worry about it. Is that okay?
So if you factor that, you'll be it.
Correct.
Like maybe 16.
So this is talking about how long it's going to take your flower pot to hit the ground, right? And we said that we're looking for time. So which is going to be a better answer? Negative 2 seconds or positive 2 seconds?
2 seconds.
Positive 2, right? You're not going to say, oh, this cat is a time traveler and his flower pot's going to hit the ground in negative 2 seconds. Right? This is not a fancy cat. It's probably like some barnyard cat causing trouble.
He's not a parrot.
Alright, so our answer is going to be positive 2 here. Is that okay?
Yeah.
Alright. So, do y'all want to see how to do it in the calculator now or later?
Now.
Well, what are we doing? Why not now? Let's do one more without your calculator.
That's what I was going to do. We'll do it because the first 2 you can do without a calculator. Huh?
I did the same. Because if you're doing like 2 different things, then you have to write down.
So what's going to happen is they're going to ask you the same types of problems, like something like this and something like the next one. They're going to have them on the inactive section and on the active section. So the inactive section, you've got to know how to do it without the calculator. That's why I want to do the first two without. And then when you get to the active section, it's super easy to do it with the calculator. And we'll do like from 3 on with those. So we're going to do 1 and 2 without the calculator first. And then we'll go back and do it with the calculator so we can check the answers. Does that make sense? Does that sound good to y'all? Okay. So do you want to do calculator on number 1 now since we're still here? Before we totally change gears? Is that okay? Alright, so let's put this in a graph. So you're going to clear everything out, go to a new graph. And we're going to type in our function. So instead of using t's, your calculator doesn't like t's, you need to use x's. So you're still going to have the same function, but instead of t squared, we'll just put x squared. So you've got negative 16x squared plus 64. And hit enter, and it's going to graph that for you. And we can't see the whole thing, but that's fine, because we wanted to know when it hit the ground, which is asking you for what? Your roots, your zeros, your solutions, your x-intercepts, yeah? So can you point to where those are happening here? We know that it's right there. Do you agree? So we need to find exactly where that happens. Now for this one, it's really easy, because you can tell that it's at 2. It's not always going to be a nice, pretty number. It may be like 2.067 or something crazy, so you've got to get that exact answer. So what you're going to do is hit menu, and we're going to analyze the graph. We're trying to figure out all these things about it. And what did we say we're trying to find? Your zeros. So what option do you think you're going to pick here? Zeros. Okay. And we're concerned about the positive one right here. So when you draw your little lines, you need to highlight around where you think that 0 is happening. So you'll click somewhere on the left of it, scroll over and click somewhere on the right, and it's going to tell you where that 0 happens. And it's at positive 2, which is what we got, so we know that we're correct. Is that okay?
Okay.
Yes.
I don't know what my calculator is.
Can you do the 2 one? You figured it out.
I know.
What?
Because I was involved.
So we'll do a lot more. Are we okay to move on to number 2 right now? Yes, no, maybe? Do you have any questions right now? No, we're not okay, or no questions?
We can move on.
Okay. All right. All right, so looking at number 2, we are throwing a ball straight up into the air, and we're going to catch it at the same height we released it. The height of the ball is modeled by this function. Graph the equation. We're going to not do that yet. What is the maximum height of the ball? So if it's asking you for a maximum, what is a maximum? How high it goes. What is that on our graph?
Your vertex.
Your vertex. How do you find the vertex? By hand.
You get
The axis of symmetry, that itty bitty little formula helps you get there. What is it? Negative b over 2a. So what is our b value? 32, so we'll have negative 32 over 2a. What is your a value here? Negative 16. So negative 32 over 2 times negative 16 is what?
negative.
Negative 32. So it's negative 32 divided by negative 32. 1. So your axis of symmetry is just 1. The x value of our vertex is 1. We want to know the maximum height. So does that want the x value there or the y value? The y value, right? Height is y. Height is y. I'm going to write that below it. So how are we going to get the y value of your vertex? Plug back in, right? We're going to take that 1 and plug it into our function. So we've got negative 16, 1 squared plus 32 times 1 plus 4. So 1 squared is just 1 times negative 16 is what?
Negative.
So negative 16 plus 32 plus 4. What is negative 16 plus 32? 16 plus 4, 20. So your vertex, let's write this to the side. Your vertex happens at 120. So that means it's going to take 1 second to reach 20 feet in the air. Does that make sense? That order for how that works? And it wants to know the maximum height. So what would our answer be there? 20. Your maximum height is 20 feet. Feet, right? Are we in feet? It doesn't even say. So we're just going to say 20. How long did it take to reach that height? 1 second. Is that okay? Do you have questions on that? Anything we're not sure about, don't quite understand? Okay. So we can graph this real quick because we basically have everything we need. We know that our vertex is at 120. So 120 is our vertex. That's like our axis of symmetry too. So anything we have on the left side of it, we'll have on the right side as well. Do we have a y-intercept here? What is it? 4, right? So we can plot that. So 0, 4. So if we have a point on this side, it's also going to be on the other side of your axis of symmetry as well. Do you agree? And then anything past that, this is us throwing the ball and catching the ball. We're done, right? That's your whole graph. You don't need anything else. So we can connect those dots. It's an awful parabola, but that's okay. And that's it. Is that okay? We stopped there because in the beginning it says you're going to throw it straight up in the air and catch it at the same height you released it. So we threw it and caught it at the same height, and that's all the graph we need. Yeah. I'm sorry? What do you mean? So our axis of symmetry was at 1 right here. So since we had that point of 4 on that side, we just reflected it over. Does that make sense? So it's not like we're like, oh, let's just hop over 2 for fun. Yeah, I thought that's where we were getting at. So yeah, we just reflected it over the axis of symmetry. So if the axis of symmetry was further down, you'd have to go. Yeah. Any other questions right now? We're okay? All right, cool. So I'm going to show you how to do this one in your calculator too. So we're going to clear out what we have, and we're going to put in a new graph. You don't have to clear it out every single time. You could just go to a new graph scheme. It doesn't really matter. I think it's a good idea to clear it out every time just in case something funky happens, but whatever you want to do is fine. We're going to go to a new graph. We need to type in the function that they gave us, but instead of t's, what do we need to put in? X's. So we should have negative 16x squared plus 32x plus 4. And this time we wanted to know the maximum height. So that's wanting to find your vertex, yeah? So we can still go through the same steps. So menu and analyze graph. But this time, instead of zeros, what were we looking for? So what do you think you're going to choose? Maximum. It's still going to give you those dotted lines to click somewhere on the left and somewhere on the right. So even though we can't see where that vertex is happening right now, we know it's going to be somewhere up here. So click somewhere on the left and then click somewhere on the right, and it will zoom out for you and show you exactly where that vertex happens. And it was at 120, which is what we got. 120. So we did menu, analyze graph, and then we were looking for the maximum, so we chose maximum here. So if you did not get 120, you may have typed in your function wrong, or you may have not clicked all the way around it looking for your maximum point. So you just got to be careful that you go all the way to the left, all the way to the right. Yeah. Is that okay? Questions? Great, so let's look at number 3. So in the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by the equation right here, where x is the horizontal distance meters from the athlete and y is the height. So our x and y are just a little bit different this time. So how far from the athlete will the ball land? So if it's saying when the ball lands, what does it want you to find? Your zeros. And it says how far, and it says that x was your horizontal distance. So it wants our x value there too. Does that make sense? All right. So for this one, our function has got a bunch of decimals. It would not be fun to try to factor that, so we're going to do the whole thing in the calculator. Is that okay? So we're going to go to a new graph and type that guy in. Do you need to write the y equals again? No, because that's already there with the f of x, right? So we'll do negative 0.04 x squared plus. So we need to find the zeros, where the ball lands, right? So you can see, like, this is where it's being thrown, and it's going to land somewhere over here. We can't see that part of the graph yet, so we need to zoom out here so that we can see that. Do you know how to do that? We played with that yet? No? So menu, and then we're going to choose Windows/Zoom. And you can, there's a bunch of different options here. One way is not better than the other. You can do Zoom Fit, which is going to try to zoom it out all the way so that it sees what it thinks you need to see from the graph. Sometimes it does great, sometimes it's not very helpful. Or you can zoom out and just zoom out where you need to. I like that better. That's just me, because I can tell it, like, here's my center, I need to go this direction, so look more this way. And so now I can tell where my second zero is going to be. Does that make sense? So if yours doesn't look exactly like mine right now, that's okay. We should both still get to the same answer. So once you can see where that zero is happening, so mine's somewhere over here. Can you see where it is on your graph? How are we going to find out exactly where that point is? Menu, analyze graph, and what are we looking for? Zeros. So click somewhere on the left. Make sure you highlight where you think that zero is happening, and it should pop up as a little dot. Click somewhere on the right, and it'll tell you where that is. So keep out, if I'm doing this, you are doing this too, because that's how you learn. You don't learn from just watching. You need to do. Is that okay?
Yeah.
All right, so what is our x value there? So that ball is going to land about 23.2 meters away. Is that okay? Questions? Not too hard, right? When you have the calculator, it's actually very easy. Do you agree? Alright, so we're going to do some more. So the next one, a frog is leaping in the air. The equation to model this is right here. What is the frog's maximum height? When does he reach the height? And when does he land back on the ground? So if it wants to know the maximum height, maximum tells you to look for what? The vertex. And then height tells you what do you need, the x or the y? The y. So this wants the y value of your vertex. When it asks you when he reaches that height, it's still talking about the vertex. Do you agree? But because it says when, does it want the x or the y now? The x. That's going to be the x value of your vertex. And then the last part, when it asks you when he lands on the ground, what does that want you to find? Your zeros. So do y'all see how it's like the same type of questions over and over and over? They're only going to ask you for two things, so it's not going to be super, super complicated. So we need to graph this, so we'll go to a new graph, and we'll type in our function. We got negative 3x squared plus 4x plus 7. For the first part, to find the maximum height, we said we would need the y value of the vertex. So how are we going to find that? I'm trying to get away from the light so y'all can see my calculator. It's not working. So menu, then what? Analyze graph, and we're choosing maximum. So you could literally highlight the entire screen if you're not quite sure where you need to go. Click somewhere on the left and all the way over, click somewhere on the right. Just make sure that you're highlighting where you think that maximum is happening. And we said we would need the y value because that's going to give us our height. So what is the height there? 8.33. when does he reach that maximum height? That's going to be the x value of your vertex. Where's that at? 0.667 seconds or whatever. And the last thing we need to find out is when he lands back on the ground. So you've got 2 zeros. Do you think that's going to be the first 0 or the second one? Probably the second one, right? Because it's when he's landing back down on the ground. So we'll do menu, analyze graph, but what are we choosing this time? 0. Make sure you click somewhere on the left of that 0 and somewhere on the right of that 0. Don't highlight both zeros because it's not going to find the one that you need. It won't do both at the same time. So you've got to narrow in on just the one that you're looking at. And I don't know about y'all, but my text is starting to overlap here. So there's a way that you can like click on it and it'll highlight it. Sometimes you can drag it around if you touch it just right. I'm not really good with the calculator, so I don't always get that to work how it's supposed to. But you can move it around to find what you need there, is my point. So yeah, 2.33, that's when he lands back on the ground. So 2.33 seconds. Is that okay? Questions on anything? We're still doing okay? Wonderful. All right, let's move on to number 5. So a football player punts a ball. The path of the ball is modeled by this equation, where x is the horizontal distance in feet. How far from the football player will the ball land? Y'all, this is exactly like number 3 that we just did, right? They just changed the function on us, and we got a football instead of some metal ball and track, right? So let's clear out, go to a new calculator, type in your function, and we want to know where the ball lands. So what is that asking you to find? Your second 0. Good. So again, we can't really see where that's happening. So what are you going to do? Menu, Windows/Zoom. You can zoom out or you can try zoom fit. Whichever one you want to do is fine. You may have to zoom out more than once, and that's okay. And if you do zoom fit and it doesn't work, you can still zoom out from there. So either way is fine. My star system has to zoom out. So to find your zeros, what are you going to do? Analyze graph, and choose 0. Click somewhere on the left of it and somewhere on the right. So about how far away did that ball land? Yeah, I got 252. Is that what y'all got?
Yeah.
Is that okay? Do we have questions? Is there anything we're not sure about or don't understand? Okay. So what I would like to do is go through and label like the next one, but I'm going to let you do them on your own. Does that make sense? So it says that Mary Poppins is using her umbrella to fly. So the equation to model their situation is right here. It wants to know her maximum height. So if it says maximum, what does that want you to look at? Vertex. If it's asking for height, is that the x or the y? The y. So this is the y value of your vertex. When does she reach that height? What does that want you to find? The x of the vertex. Then it asks when she returns to the ground. So anytime you're talking about hitting the ground, landing on the ground, returning to the ground, what does that want you to find? Second, your 0, specifically the second one. Are y'all okay to try the rest of them on your own? Yeah, like the whole rest of the page?
Yeah.
Okay, cool. So let's do that then. And we'll go over and I'll give y'all like maybe 15 minutes to do this. I probably don't even need that long.